Hi, my name is Brandon Graisley. I'm a high school math teacher, and we're going to look at completing the square part 2. If you haven't seen part 1, you should definitely back up and take a look at that. You'll need that skill in order to develop this skill. So this is what we do when we have a complex trinomial, which means that it has a leading coefficient that is not 1. This guy right here is trouble. That 3 in front of the x squared term is what makes this different from what we've done before. But we have a neat trick that makes this actually just like what we did before. There are two ways to look after this. One is to kind of look after everything on one side. I think the easier way is to divide everything by 3. Divide each side by 3. So y divided by 3. And then over here divide this whole side by 3, which is the same as dividing each part of this by 3. We can distribute division the same way we do multiplication. So over here, I'm going to keep y over 3 all the way along. And then here, let's simplify this. X squared minus 30 divided by 3 is 10, minus 10x, plus, well, 77 divided by 3 is not a nice integer. So I'm actually going to leave that as a fraction for now, and you'll see what happens in a little while. So we're going to keep this y over 3 all on its own over here on the left-hand side, and we're ready to complete the square on this side. So where we're working are these two terms right here. I'm going to split this x term into 2 equal pieces. It's a minus 10x, so I want a minus 5x and another minus 5x, and then we'll have our lonely 77 over 3 on the side. So there's the section that we're working on. Y over 3 equals, okay, well, I'm going to end up with x minus 5 as the binomial that's squared in my vertex form. So in order to get that, I need to have a constant term of positive 25, this value squared. So let me just write that out for you. I'm going to need a positive 25 in order to make that into a nice squared binomial. I can't just stick 25 in there though, I also have to subtract 25 so that these two things cancel each other out. So the equation is still true. I haven't changed my function. And I've got my plus 77 over 3 on the end here still. So y over 3 equals this middle section now. I'm going to take this plus this other little bit right here. Together is going to be x minus 5 squared. So you've got to understand why these are the same thing. 5 squared, negative 5 squared is 25. I've got 2 minus 5x's and an x squared. Expanding this binomial product here, x minus 5 times x minus 5, gives you the part that I've underlined in green right there with the extra little plus 25. Now I've got a minus 25 and a plus 77 over 3. If those were nice integers, I could combine them. If they're not, I'm going to leave that for now, because over here, see this y over 3? I'm going to multiply now both sides of my equation by 3. Do it in big brackets here. And that multiplication gets distributed. Y over 3 times y over 3 is just y. We're undoing what we did away at the top here. And now 3 times each of the things in the brackets. 3 times x minus 5 squared. Only the x minus 5 is squared, not the 3. 3 times negative 25 is negative 75. Plus 3 times 77 over 3 is just 77. See that? We undid that fractioning that we did before up here, and so I never really had to deal with any fractions in this particular example. Last little bit then, let's clean up those constant terms at the end. This stays as it is, and I'm left with plus 2. So now I have the final vertex form with all the parameters that I'm used to for making graphing this quadratic very easy. So, completing the square part 2, if you have a complex trinomial, turn it into a simple one, work with it, and then turn it back. Thanks a lot.